All right, so continuing on with our basic JSON lexer and parser, in this video we're going to take a look at getting the parser rules in place in our grammar file. Nelson?
Yep. First thing I'm going to start off with is the simplest one of our parser rules, which is simply going to be literal. Well, that's not very cool. All right, so what a literal is going to be is it's going to be a string, a number, or an identifier. So we can do number, or string, or identifier.
Okay, so now the cool thing is we should be able to start testing this.
So now I'm going to go ahead and select our literal rule, and I'm going to throw in, well, a literal, 23.
Oh,
Hey,
nice.
look at that.
All right.
We can do 23.4 if we wanted to, or not.
Now, is that just by chance being the... hang on, I'm taking a look at everything real quick. No, is that just being AntlerWorks being funny?
Quite possibly, but I might have messed up. I'm not sure. Really? Yay. Okay, so we'll take a look at the decimal places later.
What happens if you just put 0.4 since the digit is optional and run it?
Yeah, we get that. Then we get what?
See that? Have faith in what I say.
Well, wait a sec. Hold on. See, we get 34, but if we have one digit, oh, you know what? Okay, everyone. On line 12, or at least my line 12.
Yeah, I see it.
Yeah, see, what's happening here is I introduced a little bug here. And what happened is that what we're saying is that we can have one digit optionally followed by a dot, followed by zero.
Just one digit. If you want to have two digits, well, too bad.
Pretty much. So we can just go ahead and change that to a star.
So now, 0 to many before. Hey, all right. Very good.
Okay, so if we wanted to test an identifier, we get identifier. If we wanted to test a string, we get a string.
Awesome. So this whole 0 to many and 1 to many. So if you want it to change, let's see, where would one with identifier? If you took, just as an example, just playing around, on line 13 with ident mid, if you took that asterisk and you changed it to a plus, then you're going to be required to have at least two letters. So you couldn't just get away with doing like X then. So
like right now we'll do, we can't just do a singular identifier, but we can do multiple.
Exactly. That's all I was wanting to show.
Yep. And it's very similar to regular expressions.
Mm-hmm.
So now let's go ahead and jump one up and actually go ahead and write out an array. What's an array going to be? Well, an array is going to be an open bracket followed by some literals that are separated by commas. So to actually parse this out, let's go ahead and do an array. Let's say an array is an open bracket followed by a literal followed by a close bracket. And now optionally, what we can have here, are you kidding me? There we go. Oh, sorry. I don't have a semicolon at the end of it. We're actually going to be making this a little bit more advanced in a second once we get to objects, but I just wanted to show arrays using just literals. Mm-hmm. So let's go ahead and say a literal, an optional literal, because you can have an empty array in JSON. We're going to want an optional literal followed by...
Move your mouse a little. Much better. Okay, thanks.
An optional literal followed by 0 to many of these, which is going to be a comma followed by another literal. So that's how we're going to support this.
Da-na-na. Very cool.
Go ahead and clear out the errors so you don't think that there were any errors parsing that. So yeah, so now we have a parse tree that represents an array.
Awesome.
So let's go ahead and talk about objects. What's an object? An object is going to look like this. Or also objects can support quoted property names. So they can be strings or identifiers. So an object is basically going to be an open curly followed by a Now this is where things are going to get a little ugly, and we'll see how to fix that in a second. Followed by an indent or a string, followed by a colon, followed by a literal, and then let's just say followed by an closed curly, because what we're going to have to do now is copy this, paste it, again, just to get the character back there, and then do the same thing we did before, where this entire thing is optional. And then it could also follow this preceded by a comma. I don't think I did that right. See, this is what I'm talking about.
Wait, where's your comma? Your
comma?
Coma?
Coma? Oh, sorry.
There we go.
There we go. Okay, so now we have this. But this is ugly. I don't like this. Okay. So what we're going to do is we're going to factor this out into its own rule. And we're going to call this an object property. And we're going to just take all this stuff, copy it and paste, or cut it and paste it right there. So now we have an object property rule that it just matches this. So we can now replace that with object property and that with object property, and now things look a lot cleaner.
Nice.
And we get the same result, except for now they're nested under object properties.
Mm-hmm. And it's much cleaner.
Yep, so that's how you can reuse rules. Now there's one last thing that we need to figure out with this, and that is we cannot currently do this. So we need to add some awesome recursion to our grammar.
Well, even before that, what about stuffing objects into arrays?
Yeah, we couldn't do objects into arrays either.
Okay.
We would also get an error.
Mm-hmm.
So what we need to do is we need to step up. Instead of using literals here, let's go ahead and define another rule. And let's call this property or something, or value. Let's call this value. That's a good word. And a value is going to be an object or an array or a literal. Now to use this, I'm going to take this value and I'm going to replace all of the literals we're using already, so that whenever we're expecting a literal, we can now expect a value. Okay?
Mm-hmm.
So now if we run this, we get... And let's clear this out again so show that there's no errors in interpreting. Of course, we do get some warnings, but whatever. No start. Yeah, that's blah, blah, blah. Okay, so yeah, now we have this being parsed out properly, which is very cool.
Are we getting a closing, or am I missing something there, looking at all the tokens?
Actually, we might not be getting a closing...
square bracket. Or is the object getting closed off either?
No, neither of them are. Why isn't the object getting closed off? Maybe I do need to pay attention to that warning. No start rule. No rule can obviously be followed by EOF. Oh, or no, I'm doing value. Actually, I think we can fix that by doing a file is a set of values 0 to many. There
we go. Much better.
We need something for Antler to kind of latch onto to figure out when to match the EOF token.
Okay.
But now we can add additional stuff as well. Actually, that's not what I wanted to support. I don't want to support that. I just want a single optional value as a result of a file.
Cool.
So now if I still have that notepad window open, did I? I closed it. Well, if we had, imagine that we went and copied and pasted the example from earlier into this, and it looked beautiful.
Do you remember what it was?
Oh, something convoluted. It was like, I don't know, we can have an array of people with names and addresses, which are arrays of numbers, I guess. I don't know why. Followed by that. And we can see that this is being parsed out properly.
Cool.
It's kind of an intimidating graph right there, but it's all very straightforward.
All right, awesome. So is that pretty much everything that we wanted to look at for a very quick intro to our grammar files with lexing
Yeah,
and
as far
parsing?
as building out the grammar file, this was kind of the simplest, most interesting example I can come up with. Obviously, we're going to be building a fully fledged language later, which is going to allow us to actually look at the advanced features of Antler. But for now, I just wanted something as simple as possible that we can use to end up with a C# program that understands JSON.
Awesome. Okay, well, with that, ladies and gentlemen, that will wrap this video up. Thanks a lot.